Guys, hello. Um, okay. So here I am to dispel some rumors here today. I really wish Justin was here. Justin on the video. Hi, I wish you were here. He's my YouTube buddy. We watch the same thing and he's gonna like this. Anyway, so what's the probability of tossing a coin? 50-50. Okay, that's what you guys have memorized your whole life. 50-50. But is it really a 50% chance? Okay. So I'm hoping to instill some doubt in you right now. Did you make this obnoxious table, by the way? Okay. All right. So if you haven't made it, like, make it as best you can, because we're going to leave this screen and we're going to go to an applet. Hold on, I have to reset it. Hold on, I have to really reset it. Okay, so let me try to zoom in for you so let's see better. Okay, so what this thing is going to do is I'm going to hit this green button and it's going to toss a coin. Does that make sense? It's going to give the proportion of heads here and the proportion of tails here. Can you guys please watch? This is importante. Okay, so I'm tossing a coin. I didn't mean to toss that. Okay, hold on. Stop. There we go. I did it right that time. Okay, so is it really 50-50? Take a look.
100-0.
Yeah, it's 100-0. Oh no. Okay, so what I want you to see down here is this is the proportion that heads. You can't really see it, but there's a little baby line on here because it's 0 right now, because we got tails. It'll make more sense once we have more of them written in. Okay, so on your table, underneath one toss, put 0. Hold on, I lost my pen. Oh, here it is. Oh no, I'm knocking over Mr. Talbot. Okay. Okay, let me show you what I did. I put a 0 there, because this says proportion of heads, and so I got 0 heads. Are you with me?
Yes.
Okay, just checking. Okay, toss another coin. So this is 2. What's my proportion of heads? 0.5. So put 0.5. Okay, you're like, oh, well, we told you, Mrs. Talbot, that it was going to be 0.5. Haha, haha, you're proven wrong. Okay, we're going to toss again. 0.667. Toss again. 0.5. Toss it. I'm gonna have to start to be careful. Toss again. 0.4. Okay, now I have to do 5 at once. I'm gonna bring the tosses to 5. Does that make sense for your table that you see on that you wrote?
Yeah.
Okay.
Yeah. Oh.
Okay, how many do I have to do now? 50? I just screwed it up. Didn't I? Oh no. Oh, I'm good. I'm good. Okay. 0.45. Thank you for your help. Okay. So now I have to do 50 again. Okay, now 100. 0.538. 100 more, right?
Yeah, yes.
Oh. Okay.
Might be proving you wrong.
Kind of unsatisfying. Okay. And I want you guys to all realize that every time I do this, with every class, every year, my results are going to be different because it's actually tossing me a coin. So I did not get 0.5 last year. So what are we learning here? We're learning about the actual definition of probability. And so we need to define it in terms of what we did here. So the probability is the outcome of a random process. This is very important. Between 0 and 1, I've had some students turn in some tests with a probability of like 3.5 or something there. They probably should have gone back and looked at their work because they didn't like go back. Okay. I'll change my answer, 26.2. And they should have gone back and looked at their work and make sure that that was a decimal. Clearly they did something wrong because probabilities are percentages. Okay, so it's most important to me that you guys understand theoretical probability, the 50-50, is not over the short term, it's over the long term. So theoretical probability is not a guarantee of what you're going to get. Two of the things I want to talk about today are the myths of do and the myth of pot. And so I don't know if you guys talk about this way like in sports or anything, but in a random chance process, there's no hot and no do, which means that every time you do something, it starts over at 0. So if I have a spinner and I get 4 like 17 times, that doesn't mean that the spinner is hot on 4. Like gambling. Yeah, exactly. So that is the gambler's fallacy. But this is the second bit of it. So this is the not super specific part. This is more specific. A lot of this stuff is gambling related, which is, I would have done it by now if so. My recommendation is to not play it because it is almost impossible to win. Unless all of your friends at work buy a lotto ticket. Then you have to do it because if everyone else at work won and you didn't, that would be the saddest thing ever. Oh yeah, that is totally worth it. But it's totally worth it for the dream, not necessarily for the. Okay, so write this down. There's a lot of crazy words here and stuff. A lot of big words. But what this means is that if I were to flip this coin forever, then I would get to the theoretical probability of 0.5. If you took calculus, you can think of it as a limit to infinity. So the limit to infinity of this chance process is 0.5. It will go around 0.5 and it will converge on 0.5 the farther out you get. It's not going to be a perfect convergence. Not like a sine wave. It's not going to go perfectly like this and come into 0.5. If you saw here, it was close, and then it went out, and then it came back close, and then it went back out again. It's not going to be even, but it will converge to 0.5. Yeah.
Sorry, because when you were lower, that's what you do.
Oh, geez. No, it's not you. It's not you. It's long run to infinity, honey. Okay. Okay, so in your homework, it's going to give you a theoretical probability like this. Somebody calculated doing something, and you're going to interpret it properly. So you're going to say what it actually means. Okay. Over many trials, if you took a random sample of US adults, why does that matter? Yeah, exactly. So I'm trying to think of where bias could come into coffee. Maybe Seattle. If you just asked people in Seattle versus everyone drinks coffee. Where do you not drink coffee? But it says US adult, so Utah?
Right now.
Oh, that's sad. Maybe this particular example isn't as important to have a random sample, but anyway, I might think that if you asked people in Seattle, it might overestimate the population of those who drink coffee. They love the coffee there. What? Maybe. I drank coffee when I was 12, but that's because my dad is a terrible influence as far as caffeine goes. Anyway, Anyway, okay. Okay. If a researcher randomly selects 100 US adults, will exactly 56 of them drink that coffee that day?
No.
No, not necessarily. So they're trying to trick you here with only one trial because this is supposed to be over many trials. And then right here, I want to start using the letter for sample size. We're going to use this all through the rest of the year. So sample size is N. Mostly you like to use the letters because I'm too lazy to write out the word sample size. Do you have any questions about how to interpret a probability as a long run relative frequency and how to tell if you're going to have exactly that amount? Okay. Right now, we're going to talk about what a random process is. Okay. I want you guys to think and raise your hand, don't yell it out, of any random process you can think of. What is a random process? What is something where the outcomes are determined by chance? Raise hand, Chase. Chase. Dice. Jake, next, go ahead. Did you say random number generator? And is it okay with you guys if that random number generator includes your graphing calculator so we don't have to say that again?
Yeah.
Okay. What else? Nice one. Chance. Yes, right. Hat. Yes. Spinner. Beautiful. Thank you for thinking outside the box. I can think of table D. You love that one. That's the same thing as a spinner. Yes, honey. Yeah. Coin. Yeah. Not to be confused with the Edward. Coin. Get it? Okay. Pausing on that. Don't you think that Mr. Coin should have called his bonus bucks coins? Get it? Coins. I just feel like I don't know. I don't know. Anyway, I just feel like he missed an opportunity. I guess. Yeah. But the word coin is the whole thing. Oh yeah. He said he's too far into teaching now. Coins, coins. I just think it's beautiful. Okay, so in this next set of bullet points here, I want to talk about what happened with our class. We actually had a classic example of one of these bullet points happen during our hand reaction experiment. Do you guys remember how we were doing it at first and it was like left, 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 and we're like, the machine's broken.
Yeah.
Okay, that's our brain assuming that long-term runs are not good and there's something wrong with them. I can't remember which one of you guys, but there was a student in here who had like a bunch of D's on their test, and they were like, I got too many D's, I'm nervous. I can't remember. What's Luke? No?
Oh, I'm pretty sure.
Oh.
Did you use my test?
Oh,
Like, no, I was
answer
bubbling
D.
in the answer
Oh,
choices.
Oh, that was me and Grace.
Oh, was it you
That was
and
me and
Grace?
Grace.
Oh, okay. I just remember it was this corner.
I thought you were talking about like test for brain.
No, I was talking about like bubbling the same letter. I didn't even, I should have just said bubbling the same letter too many times and then they got nervous about it.
Yeah, I think I did. that.
Okay, so
Yeah.
that's something that I didn't mean it like that. No, I meant it like,
Thank you.
you understand what I was saying? Was it D though? Was the letter D? I don't know.
It was D or B. I think it was D.
But there's different versions. I don't know. I don't know. Okay. Now I just screwed up. Sorry. Okay, so first, the myth of do. Long-term Russian.
You just wrote it down.
No, I said it was a myth. The myth is real. The myth is real. Long-term runs happen. It's totally okay. You gotta like, did I tell you the story about my geometry professor in college? Okay, so my geometry professor in college, first of all, the guy was like 4'2" and his pants were way too long and they dragged on the floor. And I have a whole page in one of my notebooks of me just drawing him with his pants. But anyway, he gave us a geometry test, first test, the entire first page was true. There was like 15 questions and all were true. It was crazy. It was crazy. Oh yeah. Oh, I got half of them wrong. No. Okay, so there's a couple things to look out. I want you guys to leave this class to be like, you know, cynical about probability. I want you to be questioning, and I want you to keep your eye out for people saying that stuff is due. Keep your eye out for people saying something's hot, things are not real. Yes,
Like
honey.
with that period, like shooting like case like 2 in a row, like if there's a chance that it's like not hot.
Okay, but there's a lot of
Oh,
confounding variables.
Okay, that's fine.
So that's not a random chance process. You can improve over time. Although in this class, we will play something called trash ball. And you are going to set up a line and throw into a trash kit. And we're just going to assume independence, even though it's not really, I don't really know, I remember, but there will not be gambling in this class. Okay. Simulation. So we are going to do a simulation in a minute. It's the first page in your packet. You can actually find it. We're almost done here. Can you guys think of two simulations we've done already this year? So a simulation is something that imitates a real world problem using a random chance process. So like all of those things that you guys named a few minutes ago. We did. So we did the dogs. Do you remember the dogs thing? Okay. We actually did 3 of them. We did the dogs. What else did we do? Table D was also hand reaction time. That's it, Chase. Reaction time. And this, the chance process was built into the computer. And then the coin applet I just did. That was flipping a coin, but it was silent. Oh. Okay, so last bit in the notebook. How do you describe a simulation in an FRQ? So if you're asked to create a simulation in an FRQ, you need to know what the steps are. Last thing, and then we're going to do this World Series deal. Okay, so once you finish that, that's done for the notebook. Just slide it over to the side. And then find the first page in your packet. World Series thing, yeah. Okay, so if you don't know anything about baseball, this might be a little confusing. The best of 7 thing. Do you guys know what the best of 7 thing is?
Yeah.
Okay, we're gonna talk about it. It's okay. All right. World Series ticket simulation. How many games in a World Series? Actually want this. In baseball's World Series, the first team to win 4 games wins the championship. That's the best of 7 thing. The series might last 4, 5, 6, or 7 games. A fan who buys tickets would like to know how many games on average he can expect a championship series to last. Assume the 2 teams are equally matched and set aside such potentially confounding factors as the advantage of playing at home. Fans want to know the expected value. By the way, let's actually underline that because that's important. Expected value in our class outside in the real world is called a weighted average. Expected value is the same thing as your GPA. Like the percent times the number plus the percent times the number plus the percent times the number. The expected value for the number of games that will be played in the World Series. Describe how you would carry out the World Series simulation on a calculator or computer. Okay, now I got to tell you, this is the actual directions. The directions stop here. Describe how you would carry out the World Series simulation on a calculator or computer. And then this is actually how you would do that. It's just helping you get started because it's your first time. Let a 1 represent team 1 winning a game and a 2 represent team 2 winning. Okay, so back to my notes, I said define outcomes. That's that part. So I say let 1 represent team 1 winning and 2 represent team 2 winning. You will simulate 7 games, but as soon as one team wins 4 games, the World Series is over and you have to ignore any results that follow that. See below for an example. Okay, so we did rand int 1 to 7. Why did we not do rand int no repeat? Yeah, exactly. You have to repeat the 1s and 2s. Okay, so let's look at the results. The first 2 games were won by team 1. The 3rd game was won by team 2. And then the 4th game was won by team 1, but they haven't won 4 yet. So this is where they win the World Series because this is where they win 4. Does that make sense? Okay. And in this particular case, you would ignore the last 2 because team 1 won in 5 games. Okay. All right, so I want everyone to practice down here. I don't know why there's so much space there. Run the simulation and record how many games it took to win the series. In this example above, it took 5 games. Okay, so everybody's going to do this on your calculator. Oh, I remember. I wanted to put the directions here of how to get to this. Okay. So it's math, probability, okay. Yeah, honey. I want you to write rand int 1 to 7. Oh, I see what you're saying. This is not the same thing as normal CDF labeling. Okay. All right, so we're going with 1s and 2s. So the lowest number we want the calculator to choose is 1. The highest number we want the calculator to choose is 2, and we want 7 numbers to simulate the World Series. I'm going to combine your whole class's data into a dot plot, so everyone needs to make sure to do this, even if you're feeling Friday afternoon lazy. I see you. I see. Did I just get this? No, I didn't. I didn't. Okay. Oh, okay. What you're gonna do is you're gonna go 2, 3, 4, 5, 6, 7. Does that make sense? So you're just gonna do ran it 1, 2, and then hit it 7 times. What? Oh, yours worked? Oh, okay. I thought you guys were saying it didn't work. Others, okay. So on the older calculators, they don't have the option for saying how many you want. You have to hit the enter button that many times. Yeah, that would be bad, but okay. Now make sure whatever you're writing right here is not the same as me. Did you get the same thing? You don't have to put commas here either. I don't really know why I'm doing that. 1, 2, 1. Okay. So everyone look at Mrs. Talbot's. How many games did it take to win the World Series in Mrs. Talbot's? 5. 5 games. Okay. Now I want you guys to, in your groups, just check each other to make sure that you understand the best of 7 thing. Okay, I'm gonna bring your group a Post-it. If you could put all of the number of games for your group on this Post-it, and then bring it back over to me because we're gonna make it up. Yes, like mine would be 5. You're just gonna write, you guys are gonna write 5 numbers on there, 1 for each. Did it really? 7? 3 sevens? Unusual. Oh, I like it. Green, always green.
You know, at my work, we have like packets of green tea, so sometimes I make it when we're stuck.
That's awesome. Where do you work again?
Oh, that's where you met.
Oh, I love that place.
Really? If you come in on, I work Wednesdays, so if you come in on Wednesdays, you can get a discount.
Oh yeah, thanks, honey. I like the fried rice. It's my favorite.
I like the curry.
I'm just like such a sucker for fried rice. Like everywhere. Guys, this is on the back. You should be making it. Okay. Six, 5, 4, 6. I think that whoever wants to go to this World Series is going to be very happy with the amount of games that they get to see. These, no, they're just dashes. Like, I'm a nerd, so I use the centimeter mark on the ruler. 14. Mm-hmm.
Eight or nine, six.
8. It's okay. By the way, put yours, not mine, in here. Okay, so last thing of the period. We are going to start using probability notation in the stock. When you want to say the probability of something, you put capital P and put that thing in parentheses because we're just too lazy to write the probability of that many times. Soon it's going to have like intervals in it, like X is greater than 5 or something like that. But for now, all 7 games, so we could put X equals 7 here, but I want to ease you in. Okay, so there are 14 dots in the 7s, 29 total dots. 0.483. Now, if he likes to go to games, I think that he should be very excited about his prospects of going to all 7 games, especially if he likes, they say, garlic fries and or Polish sausage. He might get to eat those a lot. I personally like the chicken fingers basket. You can split it between like 3 people, but are you guys ready for your joke?
Yeah.
I'm ready.
What?
I'm ready.
Okay,
Hey,
you might hate it though. We'll see. Okay, let's check in. Did we interpret probability as a long run relative frequency?
Yeah.
Did we define the law of large numbers? Did we talk about the myth of do and hot? Even though Jake doesn't agree. Did we use the simulation to model a random process?
yeah.
Okay, here is the homework. And these 2 boys are sitting outside the principal's office and they say, I wish we hadn't learned probability because I don't think our odds are good.
It's a joke because they learned it.
It depends on what they did. Oh, you did lots of posties. Do you like the probability or hate it?
It's okay. It's not the worst. It's a little weird.
I know it's not, yeah.